Welcome to graphing radical functions. So radical is either we're going to concentrate mainly on square root functions and cube root functions. Square root functions are all going to look like either, so they're like sideways parabolas just with just the top of the parabola or just the bottom of the parabola, or they can look like kind of backwards. So one of those four is typically what they're going to look like. All right, we're going to go with, here are my steps: step 1, step 2, step 3. I'm going to do number 2 because it's a little bit kind of involves a little bit more. So to find the starting point, we're going to set the radicand. Radicand is what's underneath the radical. Sorry for all this noises during lunch, but the radicand is what's underneath the radical, and that's going to equal 0. We're going to set it equal to 0. So I'm going to do number 2. So I'm going to set the radicand, set it equal to 0, x plus 1 equals 0, solve it, so subtract 1. So my starting point is that the x value is negative 1. My y value is always what's added or subtracted on the outside of the radical, so negative 2. So my starting point is at negative 1, so left 1 and down 2. That's my starting point of the graph. Then I need to I want 2 more coordinates. So I have negative 1, 2 is my starting point. And what I'm looking for is, in this square root, I need to know what number can I put in for x that when I simplify this left side, it's going to give me a whole number, or integer. So what I need to do is I got to strategically, so this is step 2, strategically choose their x values. What that means is I got to think about what number can I put in for x that when I square root it, it's going to be a square rootable number. So I'm thinking about numbers like x plus what equal plus 1 equals 0, or 1, or 4, or 9. Those are my numbers I'm looking for. I don't really want anything bigger because my graph doesn't account, it only goes out to 8. So 9 really is going to be too big. So I have 0 already because I said x plus 1 equals 0. Then if you want to find the next one, I would say like what number plus 1 would equal 1? Well, that would be subtract 1, you get x equals 0. So 0 is going to be my next coordinate I'm going to choose. And when I substitute 0 in, I have y equals 3 times 0 plus 1 minus 2. So do your simplifying your right side here. So 0 plus 1 is 1. Square root of 1 is 1. Times 3 is 3. Minus 2 is 1. So my coordinate is at 0, 1. My next coordinate, I need 3. So then I have 0 is already taken care of. 1's accounted for, so now I need 4. So I have x plus 1 equals 4. So what number plus 1 equals 4? Because if I can get that to be 4, I can square root 4. So 3, right? So x equals 3. So 3 plus 1 is 4. Square root of 4 is 2. So that's what I'm looking for. So 3 plus 1. 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. Minus 2 is 4. So 3, 4 is also my... And you could do 9 if you want. If you really want to put 9 in there, you can. Oh, not 9 there. So it'd be what number plus 1 is 9? That's 8. So if you want to put that in, you can. If you want to try for a better looking graph. Ooh, too big. And that will be 8 plus 1 is 9, square root of 9 is 3, 3 times 3 is 9, minus 2 is 7, so it'll be 8, 7. And then here's our graph, what it looks like. You can always use Desmos to back up here what the graph looks like, but I would still want to see some coordinates, some work. All right, domain is how far left. The farthest left this graph goes is right here. My x value is at negative 1. It's at negative 1, and there's a closed point there, so it's equal to And that's what that bracket means, is equal to -1. And how far right does the graph go? The graph goes to the right forever, to infinity. And infinity, you cannot equal infinity, it's not a number. Range was the lowest range. Lowest range is at -2. And what's the highest? This graph goes up and up and up and up forever to infinity. So range is from -2 is your smallest, and there's a closed point there is equal to, and then it goes up to positive infinity. Left end behavior. So as x goes to blank, the y goes to blank. And the right end is, I'm going to write this out. I'll have this for you. So as the left end, as the x goes to, so I'm thinking about a coordinate. So if I put a coordinate on here, and wait, I can't pick this up at all, can I? I need to pick this point up. Oh, doesn't look like I can do what I want to do. So if I take that point and I'd move it closer to, as it's getting closer and closer and closer to the left side, what's happening? My points are all going towards, the x value is going to -1, the y value is going to -2. So x value is going to -1, the y value is going to -2. On the right end, it's going two directions. It's going to the right forever. Right forever is the x value is going to infinity. And it's going up forever, and that's the y value is going to infinity. So that's square roots. When it comes to cube root functions, we're doing the exact same thing, except that instead of a starting point, cube root functions are kind of look like, they're kind of like a squished S is what I would call them, something like that. Or they could be backwards, not the best drawing, but they look kind of like an S. The inflection point is the point kind of right in the middle. If you took the graph and you were to kind of split it into two equal looking parts. And we got to set this inflection point equal to 0, so something similar to square roots. So I'm going to do number 5. So I'm going to inflection point, I'm going to take the radicand and set it equal to 0. So that's -3. So at -3, and the y value is the exact same. It's always what's added or subtracted on the outside is your y value. So -3, 2 is my inflection point. That's the point that's right in the middle of the graph. That's going to be this point here. And then we got to look at the table. Really want 5 points, but if you got 3, as long as they're on both sides of the inflection point, you're okay. So I'm going to put the inflection point in the middle, 3, 2. And now I have to choose numbers. It is a cube root. I have to choose my x values, so it's a cube root function. Cube roots, so I got to think about perfect cubes. So 0, 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. I'm not going to go that high. And then I also have -1, -8, -27. And really all I'm going to concentrate on, because we're talking about graphing, is these 5 numbers. So I got to think about getting those 5 numbers. Well, I already got 0. That's what the inflection point does, is it equals 0. The next thing I'm going to do is what number. I'm going to go with 1. So what number can I put in for x that when I cube root, so when I cube root a number and I add 3 to it, it's going to be to 1. So it's going to be x plus 3 equals 1. Well, what number would that be? Well, that's -2. So that's going to be my next point I'm going to choose, is -2. Reason why is because when I substitute that in, cube root of -2 plus 3 plus 2. And I simplify this, it's going to work out. So -2 plus 3 is 1. The cube root of 1 is 1, plus 2 is 3. So I have my point -2, 3. So -2 and then up 3. And then on the other side, so that's 1. I can just keep going. 8, so it'd be what number plus 3, so that's the radicand, and it's going to equal 8. and that would be 5. So when I substitute 5 in, what's going to happen? Cube root of 5 plus 3, there's my 8. That's awesome. Cube root of 8 is 2, plus 2 is 4. So I also have the point 5, 4. Okay, so that's the top part of this graph. It's going to look like that. But then we got the bottom part, and this is so the left side of the graph. So I'm also going to look at -1. So what number plus 3 will equal -1? Well, if I subtract 3, that's going to be -4. So -4 is going to be another point that I'm going to have. So you have y equals the cube root of -4 plus 3 and plus 2. -4 plus 3 is -1. That's a perfect cube. Awesome. -1 plus 2 is 1. So -4, 1. -4 up 1. And then I'm also going to find -8. So x plus 3 equals -8. So that'll be -11. Now that's getting off the graph, but I'm going to do it anyways, just to look. So we have cube root of -11 plus 3 plus 2. So that's -8. Cube root of -8 is -2 plus 2 is 0. So -11, 0. So -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So somewhere out there. So the bottom part of my graph is going to look like this. And there's my cube root function. Domain. Domain's a little easier here. This is very similar to what we have been doing. Domain is farthest left. It's going to go left forever. And it's going to go right forever. So that's -infinity to infinity. And if you don't want to write that, or you could write all real numbers. That's the symbol for it. Range is at the lowest point. So the lowest is going to keep going down forever. So that's -infinity. And it's going to slowly climb, go up forever. So positive infinity. So same thing. Or you can write all real numbers. Left end behavior, that's going to be as always the same. So left end, what's happening on the left end is going to the left forever. So left forever to -infinity. And it's going down slowly, but it'll never stop going down, so that's -infinity too. So x is going to go to -infinity, the y is going to go to -infinity. On the right side, which way is it going? It's going right and up. It's going to go right forever and up forever. And there you go, there's the cube root function.